Assalamualaikum. First thing first, may I present myself first. My name is Haikal bin Muhammad Idris, metric number 303314. I will be the first presenter of my group assignment for the project. So, I will explain about I will present and explain about the introduction and also the project background. So, first thing first, this project aims to bridge theoretical concept, practical application. Our goal was to take key database principles such as entity identification, relationship modeling, normalization, and class design, and also apply them to a real-world business scenario. In our case, that scenario is a purchasing system based on a standard purchase order form. So the purchase order form served as a central business document in this project. It guided us in identifying system requirements, essential data entities, and business rules. By analyzing its structure, we were able to extract key data elements such as vendor details, item information, order quantities, shipping destination, and also these elements were then modeled systematically to form the foundation of our database design. So, our design process follow a structured approach. We started with an entity relationship diagram, ERD, visually represent the entities and their relationship. We then refine the design through normalization up to the third normal form. This step ensures data integrity, eliminates redundancy, and prevent update anomalies. Finally, we created a class diagram to represent the logical structure of the system from an object-oriented perspective. This helps visualize how different parts of the system interact. So by completing this project, we demonstrated the ability to design a well-structured database system, which is support efficient data storage, allows accurate and quick data retrieval that can be expanded in the future as business needs grow. Additionally, this project highlighted the importance of aligning database design with real business processes, ensuring that the system is both practical and scalable. So move on to the project background. To address the challenges of manual purchasing processes, we designed a centralized purchasing system. This system stores and manages all purchase order information in a structured database. With this system, users can create purchase orders by selecting items, specifying quantities, assigning vendors, and setting shipping destination. Not just that, it also accurately records each purchase order, which can be retrieved anytime for reference or import. Also, generate formal purchase order documents that can be sent directly to vendors. By maintaining a complete purchase history, the organization can analyze purchasing trends, evaluate vendor performance, and also make informed decisions for procurement strategy. So by applying proper database design principles, that ensures the system is efficient, reliable, and easy to maintain over long term, supporting both current operation and future growth.
Hi, I'm Yancy. My matrix number is 299285. Now I gonna present about the ERD. ERD before normalization actually have four main entity, which is vendor, purchase order, shift to, and also item. But since the purchase order to item, their relationship is many to many, so they must contain a additional attribute. So after normalization, the ERD become five main entity, with one additional attribute become the order item in our ERD after normalization. Okay, now I will present about the relationship with cardinality. For vendor to purchase order, One vendor can receive many purchase orders, but one purchase order belongs to only one vendor. For shift to purchase order, one location can receive many purchase orders, but one purchase order goes to only one location. For purchase order to item, one order contains many products, but one item appears on many orders also. So that's why we have to add an additional attribute, which is order item. For the relationship between purchase order to order item, one purchase order contains many order item. Order item is actually the line of item, because in a purchase order they will contain many lines of item. Okay, for order item to item, one item can appear in many order item, but one order item contains only one product. Next, I will present about the normalization process. Firstly, we have our unnormalized form, which contain purchase order number, purchase order date, vendor number until the tax and shipping. After that, we will go through the first normalization form, where we have to separate the repeating group. After that, for the second normalization form, we have to make sure there is no partial dependency. Then finally, we will get our third normalization form, where we have to make sure there is no transitive dependencies. And we will get our file table here, which is vendor, shift
Assalamualaikum
to purchase
warahmatullahi
order,
wabarakatuh.
item,
So
and
my name
also
is
order
Professor
item.
Rebel Muhammad Fauzi
This one is
and my
same as
magic number
our
is
ERD.
303562.
Yeah,
So
that's all
for the
from me.
session
Thank
5, I will explain the class diagram for our purchasing system. The class diagram is derived directly from the ERD after normalization to third normal form. Each class represents a database table including attribute, operation, and relationship to show how the system is structured logically. So for the first purchase order class, so we have the purchase order class. This class represents the main purchase order document used in the system, which is also the core entity in both the ERD and the normalized database design. The attribute in this class store important information such as the purchase order number, order date, type shipping cost, vendor reference, and shipping destination. These attributes were identified from the purchase order from and refined during normalization to avoid redundancy. In terms of operation, this class includes functions such as calculating the subtotal, calculating the total amount, and submitting the purchase order. This operation reflects the main business process involved in handling a purchase order. From a relationship perspective, purchase order is linked to several other classes. It has a relationship with order item, indicating that order item cannot exist without a purchase order. It also has association relationship with vendor and ship to, as such as each purchase order is associated with one vendor and one shipping location. Next is order item class. This class was introduced during normalization to resolve the many-to-many relationship between purchase order and item, which is not allowed in the physical database design. Each order item represents a single line item in a purchase order. The attribute include the purchase order number, item number, and quantity. The purchase order number and item number together form a composite primary key, ensuring that each item entity within a purchase order is unique. The operation in this class focus on item level processing, such as calculating the total cost for each item based on quantity and unit price. In terms of relationship, order item belongs to exactly one purchase order and is associated with exactly one item. This structure ensures data integrity and fully support the third normal form by eliminating partial and transitive dependency. Next is the item class. The item class represents the product information in the system. This class stores details such as item number, description, and unit price. These attributes are kept separate from other items to avoid data duplication, as the same item can appear in multiple purchase orders. This design decision comes directly from the normalization process, where repeating item information was removed to ensure consistency. The item class include operation to retrieve item detail and access the unit price when performing calculation in the order item class. In terms of relationship, one item can be associated with many other item record, but each other item refers to only one item. This reflects the real business scenario where the same product can be ordered multiple items across different purchase order. So for the vendor class represents supplier information in the system. It stores vendor related data such as vendor number, company name, department, address, phone number, and fact number. This information is separated into its own class to avoid repeating vendor detail for every purchase order, which aligns with the normalization principle applied in the ERD. The vendor class include operations such as retrieving a vendor detail and validating vendor information. From the relationship perspective, one vendor can be associated with many purchase orders, but each purchase order is linked to only one vendor. This relationship directly reflects the vendor to purchase order relationship defined in the ERD. So the last class is the ship to. Finally, we have the ship to class. This class represents the shipping destination for purchase order, such as warehouse or office location. The attributes store shipping relate detail including the recipient name, company name, address, and contact number. By separating shipping information into its own class, the system avoids repeating the same shipping address for multiple purchase orders, which support normalization and improve data consistency. The ship to class include operation related to retrieving and validating shipping detail. In terms of relationship, one shipping location can receive many purchase orders, but each purchase order is delivered to only one shipping location. This relationship is consistent with the ERD and reflects the structure of the purchase order form. So, in summary, the class diagram provides a logical representation of the system structure after normalization. It maintains consistency with the ERD by preserving the same entities and relationship while extending the design with operation to represent system behavior. This ensures that the purchasing system is well structured, scalable, and ready for future implementation. Thank you.
Assalamualaikum and a good evening. My name is Ammar Azman. My matrix number is T03534 and I'll be presenting about PHP MyAdmin database. So first of all, if you want to do the PHP MyAdmin database, we have to open XAMPP and open MySQL first. So this is our database, which is purchase order, and this is the 5 tables in our database. Here we can see I have item, order item, purchase order, ship to, and vendor. So this is our first table, which is table item. So in the table item, we have 3 names, which is item now, description, and unit price. So for data type, item now and description, we put varchar 100, and for data type, unit price, we put decimal. So here is the data for the item number, item no, description, and unit price. As you can see here. Next is for table order item. We have also 3, which is PO, PO no, item no, and quantity, QTY. And the data type for P no and item no, we put varchar 100, and for quantity we put integer. So this is the data for the PO no, item no, and quantity. For the next table is the table purchase order. So we have 3, 4, 5, 6 name. So in PO no, we put varchar 100. For PO date, we put the data type date. So for tax and shipping, we put decimal. Vendor no and ship to no, we put varchar 100. So this is the data for each PO no, PO date, tax, shipping, vendor, and ship to no. And for the next table is our table ship to. So we have ship to no, ship to name, ship to company, ship to address, and ship to phone. And all of it we put data type varchar 100. And this is the data for the ship to no, ship to name, ship to company, ship to address, and the ship to phone. And next and lastly, for our table vendor, we have vendor no, vendor company name, vendor debt, vendor address, vendor phone, and vendor fax. And all of it we put data type varchar 100. And this is our data in the table vendor for each vendor no, vendor company, vendor debt, vendor address, vendor phone, and vendor fax. So that is all from me. Thank you.